Okay, hello and welcome to another day writing a scheme interpreter in Rust. As you can see by the title, we're going to be working a bit more on bytevectors today. We'll also be maybe looking into ports depending how things go, I guess, if we're brave enough to try it. Ports kind of have me worried. I'm not sure how we're going to be able to represent like an abstract like essentially like a file or network handler, but that should be interesting at least. Okay. Let's find where we were yesterday. So we implemented vector copy and vector append, and we also, oh sorry, those are the vector functions, not the byte vector functions. So we did copy, we did append, and I gave another look at like this other version of byte vector copy that accepts a to and an at, and I kind of understand it now, so we might try that too. I'm also not sure, did we finish UTF-8 to string? I don't know if we covered every edge case. Oh yeah, we did. Beautiful. Off stream, I also started string to UTF-8. Very nice. What do we call this thing? So that's interesting. This can be achieved without allocating storage by making sure to copy in the correct direction. But I thought bytevectors were fixed size. Wouldn't you have to allocate a new one if you append a new element to it? Oh, I see. I think that's what this disclaimer is saying at the start. Yeah. Two has to be bigger than at. Or at least the same size. Greater than or equal to. Let me try something here, bear with me. Okay, so this is going to copy elements from a range. So it's the byte vector we're writing in or copying into, the index from that we're starting at, and then from is the index, or from is the byte vector we're copying from. So we'll have a number in between here. then this can optionally take in start, or it can take in start and end. Rust FMT is killing me. Look at that. Holy cow. Still can't get over how clean this this pattern is. Okay, so now we need to make sure we need to make sure the range that is shown, or that is passed in between to and at, is greater than like the size of from. And in the base case, we don't get start or end, so we're just assuming that it's the size of the whole byte vector. I think it's like that, right? Oh, wait, flip this. Wait, does that work? We have a byte vector of 3, and we start at 0, so we want to get all 3 elements. So if 3, because like 3 minus 0 is 3, course is greater than the length of b. Yeah. Then we return an error. So what do we do now? just gonna write it like this, just help wrap my brain around the indexing I have to do here. Wait, what is this saying? Oh, I keep forgetting the question mark to implicitly return the error if it gets one. Okay, right on. In a Alice, what am I doing here? Typo. What? Oh, I think it's just implicitly typing. We're expecting this to return results because we still haven't returned anything. I think we're good. Oh wait. Yeah, so it should return should return void. Beauty. Okay, right on. I don't know why. Programming on stream, my mind goes blank, and it's actually crazy. So that, honestly, this is probably better than our pace yesterday. It's going to be a very, very similar thing here. We just have to check for start as well before we do this. And we'll also have to get... Oh, it's going to be weird. We can't just get like a sub byte vector with this guy, because this is not a mutable reference. That's just getting us a copy of the data. Interesting. Yeah, oh, how do we do that? I don't even think we have to check the end index here, right? Because in this case, before we actually get to like copying over the data, we'll just check that the end, like from start to end, is like essentially the same as the range that they want to do with at. But yeah, I guess we just have to. Oh, how does that work? I think it's b dot set I plus start. Obviously that's going to error out because you can't add, because of our phenomenal number wrapper type. Can't just add it to a normal number. Let's look at this one more time to make sure I'm getting it right here. What did I just do? Firefox, what is going on? Okay. So we first check that. Or what? So it's the difference between to and at. Oh, is less than. Shouldn't it be an error if it's either? Right? Surely that should also error out if we pass in if 2 is like a length of 5, right? And at is let's just say like 0. So we try and copy in the whole thing into the from vector. Wait, dang it. I wrote it backwards here. should be like this. Yeah, we're writing into vector B. And then it'll be the same here. But we just got to replace b.len with end. Show my editor here. It's hard to, I don't know why, it's hard for me to keep track of which scene I'm on. Anyways. So this is the destination byte vector. And then this will be what we're copying from. Wait, what's going on here? Oh, but, oh my gosh. That's crazy. I was like, why isn't this working? What's going on? Because I typed out A, and A was what we copied from. Like, I know this. Okay, yeah, that worked. Let's redefine B. Try it with a starting index. So if we start from index 1 and then start at index 1 of A, B should be 0, 2, 3. Cool. Cool. Yeah, looks like we got it backwards. Nice. Love to see it. Actually, why am I using these dumb names? So that should be A, that should be B. Let me actually name these what they should be named. Yeah. Yeah, I like that a lot better. Destined from. Okay, let's try that again. Okay. Bytevector copy from B, starting at index 1, or 2B, starting at index 1, from A, starting at index 1. What does that give us? Nice, we did it. Right on. How does that work? So 2 minus 1. Oh, Ah, something got mixed up here. I assume the answer is no, but can I just enumerate a slice? No. Okay. Just checking. That'd be cool if you could. Okay, yeah, so destination, the difference of the destination range should be less than the from range, like how it is here. Yeah. I think I've forgotten something. Wait, what? Why did I do that? It should be des.set I plus at, and then this should be should just be the whole thing. Which effectively is the same thing, but it's not the same thing as what we did down here, right? Because this should be start. And it should be I plus at there. I really need to add autocomplete to my REPL. Holy cow. That'd be nice. And for those curious, like, I wrote my own library for this REPL to manage like standard I/O, which means I'm manually managing standard I/O, and like I'm like re-rendering each line when you type something. That was a pretty fun project, but there's some things that are missing. Like I don't have autocomplete. New lines get funky. I have to fix that. There's no syntax highlighting. But yeah. Yeah, so how much will this copy? That's what I want to find out. The whole thing. That's not what we want. Because we did I+1, I think. Oh, yeah, that did it. That's so cool. Yeah, so let's just try and get, let's try and get 1 into the 3rd position. Or not, like at index 2, I guess. Wait, let me... Scary thought. I don't know if ranges in the scheme spec think that you should... I don't know if they assume that the top range is exclusive, like the way Rust does it by default. Okay, so we do B1, so starting at index 1, we go 0 to 2 from index A, or from byte vector A, we go index 0 to 2, so 10, 20, 30. What is happening here? Why is that how it works? How does the 10 get at index 0 in byte vector B? Let's try this in the online scheme interpreter. Oh, I was reading them backwards again. The classic. I thought this was A for a second. Yeah, that makes sense. And okay, so it's top bounds exclusive too, because it did 0 to 2, but it's only 2 elements instead of 3. Nice. Okay, yeah, so let's try and get 1 into 3, into position 3 of byte vector B, just to make sure this works. And because it's fun. Yeah. Wait a minute. But I have to do like 2, 2? Is that a thing? I see. Okay. Yeah, I guess we didn't. It's not if end is greater than or equal to, it's just if it's greater than, which is what we want so we can get the last index. Yep. And then finally, if we do it for 1, boom. Hey, right on. That looked so scary yesterday. We got it relatively painlessly, I guess. Right? Again, Rust FMT is kind of making this look gross, but that's fine. Just make sure everything is simpatico here. Wait, what? What line did we remove from? Oh, yeah, we just renamed that. Yeah. That's fine. Yeah, so now that we know that, we can actually implement it for the normal vector too. It's not too bad. Where's vector copy? I think we can just directly go enter dot enumerate now. What? Oh. Right, this is not the normal, like, Rust vector type. This is our wrapper for it. Or is it? I'll have to find it in a second. Just gonna grab some water really quick. I'm starting to get thirsty. This Pepsi is not cutting it. So yeah, I will be right back. Okay, we're back. And we got our water. Okay, we are all set up and good to go. Oh. Of course. We have to clone expressions in this interpreter because we can't have nice things. Actually, so I am very curious, like the runtime overhead that we're incurring, because the expression type is not copyable. It has heap allocated memory, right? Once this is all said and done, I would really love to do some benchmarking and some profiling and see like just how much cost all this cloning is incurring. I have a feeling it's a lot, but that's fine. The alternative would, I don't think I could even implement the alternative, but even if I could, I think it would be a lot of work, even if I knew how. Oh wait, I don't have to borrow leave here. What am I doing? I didn't write an error message here. Oh, that's bad. Right. We can't immediately borrow and then cast it to something else because the value will be dropped. I'm not super happy with how noisy the syntax is, but I can't think of something better off the top of my head. Yeah, it's fine. It's fine. It won't look pretty, but it's fine. When in doubt, I just kind of borrow the error messages from the online interpreter here. So if we pass in like just number 1, you know, that's probably a much better way to say that. Oh, I should definitely do that. That would be nice one day to have specific argument error messages of what we got versus what we expected. Yeah, so let's see if this works now. It's exciting we got this because those were the only 2 things that were missing from both vectors and bytevectors. Define test as, I guess same, just send the same example just to keep it simple. Nice. Aha, okay, so we already found an issue. Something's happening in this set function here. Why is it doing that? Oh, huh. Whoa. Wait, does that happen with... Oh, that's weird. Does this happen with bytevectors too? And then, okay, so it does happen. The ultimate question is, does it happen in the online interpreter? That's what the people want to know. Yeah. Okay. Yeah, no, that makes sense. That makes sense, because we're trying to copy more elements than are available in our destination by vector and vector. But yeah, this nice. Yeah, I think I'm pretty sure it works. I know that's that overwhelming vote of confidence in the code here. Dang it, I wasn't sharing that. I just got it to work. Yeah. Yeah, what's next here? That might genuinely be the last vector and byte vector thing we have to touch, period, which is crazy. Did this off stream. I did string to UTF-8, like I mentioned before. We did that. We did the normal byte vector copy. We did set, I believe. Again, baffling decision to call it byte vector U8 ref and U8 set. Like, why? If it's a byte vector, what else is it going to be? we have append. We obviously have the constructors, like the basic one in make by vector as well. We have the predicate. Yeah, that's crazy. We can actually merge this in right now. We love to see it. So that's huge, honestly. We should probably increment the version number too. Now that we have both vectors and bytevectors, that's probably a good time to do it. Nice. So now that that's merged in, I think the play is we just kind of look into ports for a bit. I don't know how this is going to work out. Before anything, I guess we just read about it. That's probably the play. Where's I/O? Input and output. Okay, ports represent input and output devices. An input port is a scheme object that can deliver data upon command, while an output port is a scheme object that can accept data. Whether the input and output port types are disjoint is implementation dependent. Interesting. Bit of leeway there. Different port types operate on different data. Scheme implementations are required to support textual ports and binary ports, but may also provide other port types. So just text and binary. Okay. Surely Rust has some kind of port abstraction. I think that's like IO reader and IO writer. Well, yeah, I guess let's just search. Maybe there is just like a... Oh. Excuse me. Oh, wow. This might actually be what we're looking for here. The right FMT right is for textual ports. Textual sounds weird, just text. Chars. UTF-8 encoded chars, and then IO right is for binary data. So we have a trait that is useful. We have two, but what implements them that we can use, right? I see. So I think these bytes only get sent when we call flush on the buff writer. These 10 are all grouped together by the buffer and will all be written out in one system call when the stream is flushed. Yeah. Interesting. Okay, well, yeah, I guess I'm going to read a bit more about ports. Off the top of my head, my initial gut reaction, right, is we have an enum called port, and it can be either text or binary, and I'm still not 100% sure if if buff writer is specific to it. Buff writer might be useful to use, but I'm still not. What I'll have to look for before next stream is the specific structs that you typically use for a stream of text, and then a stream that you typically use for a stream of binary data. And then hopefully, once we do that, we can just, once we have that enum, ideally, it'll just kind of work. And not only work, but work with multiple different streams of data. But I guess we'll find out. Thanks for joining me for today's live stream, everyone. It was fun to close out Bytevectors, and I will see you all again when we try and tackle I/O ports and make some progress on that. Right on. Have a good one.